Hello friends, welcome to lecture number 21. Today we will start a new chapter, that is your current and electricity. Okay, so to start with, the first topic will be current. From the very beginning, from class 10th onwards, we know that whenever a charge flows, it gives rise to current. So with that definition only, we will start our today's class. That flow of charge rate of flow of charge is called your current. This is called as your current. Okay, then I average will be your charge flown divided by total time that is delta q by delta t. What will be the unit? Unit is coulomb per second, which is written as ampere. Okay, then what about I instantaneous value of current will be how much? It will limit delta t tending to 0 delta q by delta t, which is dq by dt. Okay, so I is equals to dq by dt, the formula which we write. This is your instantaneous current, not your average one. Then current is a scalar quantity or a vector quantity? It is a scalar quantity. Okay, now we should understand how the current flows in a conductor. So to physically understand it, I will take the help of a simple diagram. Okay, what it is? We will take a conductor of length L. Okay, and it will be connected to a potential V. This is higher potential, this is lower potential. The potential here it is 0. Okay, so it is quite obvious, if this side is V, this side the potential will be V, and this side the potential will be 0. Okay, and the electric field will be along this direction. We have already read that the direction of the flow of electron is opposite to that of the current. So in order to understand the flow of current in conductors, let us not consider the motion of the electron which moves in this direction. For this case, we will consider positron, and positron direction is the current direction. Okay, for our understanding we will take this concept. Followed. Now what happens, that once we apply a potential difference to a conductor, then what I will have three different positions. So let me take it as this as position 1, position 2, and this is a position 3. Now since this side the potential is V, then what will be the energy here? Energy will be your E into V. Energy will be E into V. Okay, now when it travels to the other side where the potential is 0, so your energy will be 0 here. So what does it mean? It means that when the positron starts from side 1, then it carries an energy of EV, and during its motion through the length L of the conductor, once it reaches position 2, there the value of the energy becomes 0. Okay, then the positron comes to the position 3, and this potential difference, always remember, the battery, this potential difference is supplied by whom? It is supplied by the battery. Now remember always, battery is a source of energy, it doesn't give charge. A wrong concept is there in the mind of the students, that battery is a source of charge. No, battery is a, remember, source of energy. Okay, so what happens when the positron comes to the position 3? It doesn't have any energy. Then who gives the energy? The battery gives the energy to the positron, and then again it comes here with full energy, and then it tries to distribute the energy to the conductor, and at position 2 the energy again becomes 0. So this is how the motion of the positron takes place, and this is how the current flows in the circuit. One question might come to your mind, that where this charges, where this energy goes. Here the energy is EV, but here the energy is 0. Where the energy goes? The energy is taken by whom? The energy is used by the conductor. The loss of energy, the energy is used by whom? The energy is used by the conductor. Okay, and the conductor can be of the form like your fan, light, bulb, anything. Okay, those will be the conductor. So this is the basic method to understand what is the how the current flows in a conductor. Okay, now we have to derive the expression for the current. Okay, we have to derive the expression for the current. Now we will go for the derivation. Okay, so this is for your understanding, and now we will derive. So while deriving this expression for current, we can say that your energy of the charge carrier where we have considered the positron, the energy of the charge carrier at position 1, what it will be? It will be EV. But energy of the charge carrier at position 2, at 2, how much will be that energy? It is 0. Okay, now where this energy is taken? This energy is taken up by the conductor. Followed. Now the how many charges are present, or how many positrons are present in this conductor? The number is very large. Large number of positrons are present. Okay, for which now we introduce a term n. So what is n? N is number of free charge carriers per volume. Okay, this is the meaning of n. Okay, now what happens? The first point is, when there is no electric field is not there, your charge carriers which are the electrons have speed. And they move randomly. Followed. And there is no net displacement. Therefore the velocity is equal to 0. That means, suppose it starts its vibration from point A, it goes in this manner, zigzag manner, and then comes and reaches here only. Since no displacement, the velocity is 0 at this point. And this happens when there is no electric field. But situation changes when electric field is applied. There is a small displacement, implies velocity not equal to 0. Okay, that means it starts from here, it goes in zigzag manner, okay, and ends up somewhere here. So small displacement is there. Okay, so since small displacement is there, velocity is not equal to 0. It will have some velocity. So the average velocity, because this is not for the one charge carrier, one electron, so many electrons are there, so we'll talk about the average velocity. So the average velocity will be d by t. D is the distance or the displacement. This is the displacement here. Okay, and how much time it takes. Okay, the average velocity is d by t. Now this average velocity is called the drift velocity, and it is denoted by Vd of the electrons. Drift velocity of the electrons. Okay, and your this Vd direction will be in which direction? The direction of Vd will be in the direction of your electric field. Okay, this is very, very important. This is your drift velocity, and the direction is same as that of the E. Okay, now so many electrons are involved here. So to make our life simpler, we will have some assumptions. We will take an assumption. Okay, this assumption is required in order to calculate the expression for current. What is the assumption? The assumption is your charges move symmetrically. Charges move symmetrically and each have a velocity which is called as your drift velocity, Vd. So if you look at the picture, if you have this conductor, here the electron moves with Vd velocity. All of them will move with the Vd velocity. So this is the basic understanding before getting into the derivation of current expression, and this is the meaning of drift velocity, and this is the assumption we have to take. Okay, now we have to find out your current expression. We have to find your current expression. Okay, followed. So for this current expression, again we have to consider a conductor. Okay, we take a conductor here. The conductor is of length L. Okay, and the electric field is there, E is equals to V by L. Okay, and I have not shown that it is connected to a battery, but still it is well understood that the conductor is connected to a battery, for which it provides a potential V here. Okay, now what will happen, I will take a cross section here. Now this cross section will have some electrons, right? After a time dt, let it be cross section 1. After time dt, these electrons move to the cross section 2. Okay, then what will be the distance covered? The distance covered here will be drift velocity into time dt. This is the distance covered, and here A is your area of cross section. Area of your cross section. Okay, clear. So in time, so remember this conductor is connected to a battery. Okay, so in time dt, electrons in cross section 1 must have traveled a distance Vd into dt to reach cross section 2. Okay, then what will be dq? Dq will be the number of charges crossed the cross section. Number of charges crossed the cross section in time dt. This will be your dq. Okay, now how much will be dq then? Dq will be n into a vd dt. So the term which I have written in the bracket, what it is? It is the volume, okay, into the electron charge. What is n here? N is the number of charge carriers per unit volume. Okay, I hope you have understood. Then what will be your current? I will be how much? Dq by dt. So if you go for dq by dt, then your dt gets cancelled out. So what is left out? N E A V D. So this is the expression for current in terms of drift velocity. This is your expression of current in terms of drift velocity. Okay, now again question comes in CBSE that you have to establish a relationship between current and your relaxation time. So we have to derive an expression for current in terms of tau. And what is this tau? This tau has got the name called relaxation time. It is your relaxation time. So if you want to know what relaxation time is, this is time between two. Relaxation time is time between two collisions. Okay. because once the electrons are moving in a zigzag in a particular manner, then they will definitely collide. Okay, for which you will see that the time between the two collisions is your tau. So we have to find an expression for that. Followed. So again, let us consider your conductor, cross section A, and let us imagine that the positrons are moving. For simplicity, we have taken it, and the electric field is along this direction. If electric field is there, that means the conductor is connected to a battery. Okay, so if then what will be the force on your positron? This will be equal to E into electric field. Then what about the acceleration? The acceleration will be equal to how much? E by m. This will be your acceleration. Followed? So in reality, the charge carriers have acceleration, but for simplicity, we had assumed the motion of the charge carriers is not accelerated. Rather, they all move with a constant velocity. And what is that velocity called as? It is your drift velocity. Okay, followed. Now since it is accelerated, there will be collision, and we will one more term will be introduced, that is lambda. What is lambda? It is mean free path. Okay, what do you mean by mean free path? It is the distance between two collisions. It is the distance between two collisions. Okay, so two new terms you will come across. One is your relaxation time tau, other one is your mean free path. Okay, now we will consider that so many large number of electrons are moving. Okay, so suppose the first charge carrier I am talking about, its initial final velocity is v1, will be equal to how much? u1 plus acceleration time is tau 1. This is for the first charge carrier. Then for the second charge carrier, we will consider v2 will be u2 plus a tau 2. If I go on, we have n number of charge carriers. So vn will be how much? un plus a tau n. Okay. Now remember that your initial velocity will be 0, because initially the electrons, when they start, they are at rest. So u is going to be 0. So if I want to calculate what will be V average, V average will be V1 plus V2 plus dot 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 plus Vn divided by n. Okay, and in this V1 what I will write? A tau 1. Why A tau 1? Because U1 is 0. Similarly for V2 I will write A tau 2. Why? Because U2 is 0. So a acceleration can be taken common. We will have tau 1 plus tau 2 dot 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 tau n divided by n. Okay, and so V I can write as A tau by A tau. Okay, we can write down V is equals to A tau. Followed? Now again we know that the acceleration, what was the acceleration? Acceleration was E by m. Okay, so the acceleration was equals to E by m. So what will be V? So what is the V? V is the drift velocity basically. Average velocity means the drift velocity. So what will be drift velocity then? It will be equal to A into tau means E by m into tau. So finally I can write for drift, this V is nothing but the average one, and the average one is your drift velocity. So Vd will be, I can write, is equal to E by m into tau. So this is the expression which you have to remember. Using this expression, you can find out the current and drift velocity relationship. Okay. So we have already derived your current I is equals to NEAVD. So this is equal to NEA. Instead of VD, what I can write? EE by M into tau. So this gives you NE square tau A by M into E is equal to I. So this is one of the relationships between your I and tau. This is also one important relationship. Now many informations can come out from this expression. Many informations can come out. Okay, let us go one by one. Note. Now I can write I is equals to NE square tau A by M. Now instead of the electric field, what I can write is V by L. Why? Because E is equals to V by L. Okay. So if I write that, then what will be V then? V is equal to ml divided by n e square tau a into, I'll write again, tau a into your I. Okay. And we very well, and this is nothing but a constant term. This is a constant term which is known as your resistance. Is known as your resistance. Then the question comes, how do I know it? Because we very well know from Ohm's law, V is equal to IR. Okay, this is your Ohm's law. So if you compare both of them, it is quite evident. This implies my R is going to be ml divided by n e square tau a. Okay. Now if you look at, your R is now going to depend on whom? Depends on R, depends on whom? Depends on tau. And your tau depends on whom? Tau depends on temperature and material. Temperature and material. Okay. So this is one of the very important outcome from this derivation. Now the next thing comes, that how to incorporate mobility. This is also important. How to incorporate mobility. Okay. So mobility is denoted by mu e. There are two types of mobility basically. Mobility is for mu h and mu e, which we'll read in detail in semiconductors, last chapter. So mu h is your mobility for holes or positrons. This is for your electrons. Okay. So we will consider here mu e. Okay. What is the definition for that? How is mobility defined? It is defined as drift velocity per unit electric field is called as your mobility. So mu e will be how much? Is equal to Vd, drift velocity, by your electric field. Then what will be your drift velocity then? Mu e into E. And we already know that your current I is equals to how much? NEAVD. So if I substitute the values, NEA mu E into E. So question can come to express current in terms of mobility, express current in terms of your drift velocity, express current in terms of your relaxation time. Any one of the derivations can come. Okay. And one more important thing which we can also find out from here, that mu E, we know mu E is equals to Vd by E. Okay. And what will be your Vd then? E tau by m, which we already know it, into 1 by E. So E gets cancelled out. Your mu E can also be written as E tau by m. So these are the expressions which will be required while solving problems, right? So this is it for today's class. I hope everybody must have liked the video. Like and share the video, subscribe it. Any queries you have, you can mail me in the mail ID which is given below. Thank you for your kind patience.